Lesson 3.7, Implicit Differentiation. Now we have two problems here, and they are actually the same equation for this circle that you see on our graph. And we're going to show how it's much easier, instead of solving for y, to be able to use implicit differentiation to differentiate this equation. X squared plus y squared equals 4. So we're going to take this derivative, and when we take the derivative of these problems, the very first thing you're going to do is just take it like you normally do. The only difference is when we come to this y term, we take the derivative of that y term, and then we also multiply it by dy dx, or the derivative of y with respect to x. So when I look at this, the derivative of x squared is 2x, and the derivative of y squared is 2y, and we always put times dy dx. And that is equal to the derivative of 4, which is 0. Now what we want to do is get the dy dx term by itself. So the first thing we're going to do is subtract the 2x, so I have 2y dy dx equals negative 2x. Then I'm going to divide by the 2y, so I have dy dx equals negative 2x over 2y, or negative x over y. And if we look at, if I plug in 0 for x and 2 for y, I get negative 2 over 0, which is 0. And if we look at that point, 0, 2, right here, the slope of that line at the point 0, 2 is indeed 0. And same thing if I plug in 0, negative 2, which is 0 over negative 2, which again gives me 0, which gives me this point right here, which again the slope is 0 at that point. Okay, so let's move on. And we have the example x squared y plus xy squared equals 6. So the first thing we're going to do is take the derivative, and all the rules still apply that we have normally been using. So when we look at this problem, so as I said, our rules still apply. So when we look at this term here, x squared y, they're being multiplied together, so we have to use the product rule. So I'm going to use my f is equal to x squared, and g is equal to y. F prime is equal to 2x, and g prime is equal to 1 times dy dx. Every time we take that derivative of dy dx, we have to put that term in there. And then for this second set, I have x times y squared. So for this second set, f equals x, g equals y squared, f prime equals 1, and g prime equals 2y times dy dx. So let's start out with this first one. The derivative of x squared times y is 2xy plus x squared dy dx plus 1 times y squared, so it's y squared, plus 2xy dy dx equals 0 because the derivative of 6 is 0. So I need every term with dy dx on one side, every term that does not have the dy dx in it on the other. So I'm going to keep the x squared dy dx plus 2xy dy dx equals negative y squared minus 2xy. Now factor out the dy dx, so it's dy dx times x squared plus 2x y equals negative y squared minus 2xy. Then I'm going to divide by the x squared plus 2xy. So dy dx equals negative y squared minus 2xy all over x squared plus 2xy. Okay, so let's try one more before we finish for today. The equation of the tangent and the normal to the curve x cubed plus y cubed minus 9xy equals 0 at the point 2, 4. So the very first thing we have to do, of course, is to find the derivative of the x cubed plus y cubed minus 9xy. So of course the 9xy is the product rule. So I'm going to equals 9x and my g equals y. Go ahead and make that minus 9x. So f prime equals negative 9 and g prime equals 1 dy dx. So my derivative of this equation is 3x squared plus 3y squared dy dx minus 9y minus 9x dy dx equals 0. So again, I'm going to keep all the terms with dy dx on one side, move the rest to the other side. So I have 3y squared dy dx minus 9x dy dx equals 9y minus 3x squared. Then I'm going to factor out dy dx. So I have dy dx times 3y squared minus 9x equals 9y minus 3y squared. Then dividing by the 3y squared minus 9x gives me dy dx equals 9y minus 3y squared over 3y squared minus 9x. And this should be, sorry about that, but this term here should be 3x squared. Sorry if that threw you off. Okay, so this term here is our derivative. So we're going to have to plug in the 0.24 in order to find the slope of the tangent line to be able to write that line. Slide. All right, so we said that our derivative was equal to 9y minus 3x squared all over 3y squared minus 9x. And it's at the point 2, 4. So we're going to plug in 2 everywhere we see an x and 4 everywhere we see a y. So I have 9 times 4 minus 3 times 2 squared my multiplication sign a little bigger there, and all over 3 times 4 squared minus 9 times 2. So the slope of this line when I do this math which gives us 4/5. So the tangent line has a slope of 4/5. So I'm going to use the y equals mx plus b. My y is 4. My slope is 4/5. My x is 2. And I need to find my b. So I have 4 equals 8/5 plus b. So b equals 4 minus 8/5. Which b is then 12/5. So the equation of my tangent line is y equals 4/5 x plus 12/5. All right, so now the last thing we need is the normal to the line. So I already have the slope at the 0.24, which is 4/5. Let's get a new screen here. My slope at this point is 4/5. And my point is 2, 4. Now this is the slope tangent to the line. Normal to the line, remember, is a 90-degree angle. So my normal slope equals negative 5/4. So my equation using y equals mx plus b is 4 equals negative 5/4 times 2 plus b. So I have negative 5/2 plus b. So b equals 4 plus 5/2. So b equals 13/2. So the equation of the line normal to that curve at the 0.24 is y equals negative 5/4 times x plus 13/4. Okay, well, thank you very much. That's enough for right now, and we'll see you.